Hey guys, we're back at it with AS Biology in a single day, back at day 12. So, definitely seen some improvements. Stats for this paper are about 72.4%, so managed to break into the 70s. And this is, I think, the fifth paper of the paper 2 series, so about 3 left. But yeah, also I was a lot faster with this. Actually, I don't think I was faster, but this is sped up 35x, it's about 4 minutes still. So, yeah, that's about 140 minutes or just over 2 hours. So yeah, same sort of speed, but good improvements in accuracy, which is good. And I learnt a bit in this paper, so I just recapped the root squash practical. I think I learned a bit more about prokaryotic, eukaryotic cells. But yeah, most of the stuff was kind of repeated, and the biggest problem I had with this paper and most papers so far is just I'm not able to properly predict the mark scheme. So I'm trying to improve at that, trying to read the question carefully to see what they're actually testing. And then yeah, another tensile strength question. Don't think I got full marks in this first one because this wasn't really related to tensile strength, it was more about the structure of cellulose. That was another thing I learned, how cellulose is arranged in the cell wall, creates that matrix embedded in pectin to hold it in place, prevent it from sliding, and also crisscross structure, which gives it more strength in different directions. So that was good. We have another practical question, which is fine. So yeah, so practicals generally 5 or 6 marks. When they're 6 marks, they need a bit more explanation about the specifics. But yeah, just I think I understand the root squash practical quite well now. Analyze and deduce questions. Again, it wants you to look at the data, but it also wants you to use a bit of your own knowledge and just read the questions really carefully to make sure you can see what they're trying to test. Yeah, this was fine. Comment, this is similar to deduce, but make sure you look at the ranges because there's always a lot of marks in those. Oh yeah, the gene sex-linked disorder. So here I had to learn a bit about, well, not learn, but I had to understand how to articulate the fact that on sex-linked disorders it's only going to have an X or Y. It's only going to affect the X or Y chromosome, which is why you can't use the Hardy-Weinberg equation, because that assumes that every gene has 2 alleles coding for it, whereas that's not true if it's only on the X or only on a Y chromosome. So yeah, got through that, and now we're at about 70%. Also learned about acetation. I can't say it, but acetylation. I'm gonna just say that. Not really the opposite of methylation, but similar. Acetation basically allows genes to be expressed, whereas methylation suppresses genes. Again, just learn about all of the mesosomes. These are a bit weird because some people don't even think they exist and might just be produced as an artifact when you take the electron microscope picture. But I guess we'll learn about that. I guess maybe someone will find that out in the future. So yeah, I just need to get my phrasing right. When it's always about bacteria, you always want to say things like decomposition, multiply, growth, and just be specific with the phrasing, because I think that's the biggest problem people face with biology is the mark schemes are quite difficult to sort of know what they're trying to test. So that's why I'm focusing a lot on actually getting a mark scheme. You can see I'm just using the flashcard method here, not actually writing to save time, but still articulating the points. But yeah, thanks for watching, and that was day 12. See you guys in the next video. Bye.